Hello, everybody, and thank you for coming this early to Digital Dragons. I know it's 10. I know we also had an awesome party yesterday to kick it all off. And today I will be opening the programming and technology track with the talk about single player to multiplayer and how to adjust your gameplay dev mindset. I'm Timothee Engel. I'm the technical producer at Photon Engine, and we have been building multiplayer technology and helping game studios build multiplayer games for the last 20 years. We're based in Hamburg, and well, most of the largest multiplayer games run on our platform overall. Today, the goal is to help you convert these unknown unknowns that you have when coming from single players to known unknowns if you decide to step into the multiplayer space, so that you know what you should be looking out for or what you should still be learning about to be effectively developing a multiplayer game. So what exactly will we be talking about today? First off, we will not be talking about deterministic technology. That is a separate multiplayer stack, and today we will be focusing on state transfer technology. We will be discussing high-level concepts. This is not an in-depth tech talk about how to develop these technologies themselves, but rather how to apply them to your gameplay development. Third of all, we will definitely also be talking about what it means to include multiplayer in your game dev pipeline. And of course, as I mentioned before, since we're talking about state transfer, we will have a quick primer on what that actually means in terms of technology. Finally, but just as importantly, we will be going over some of the common concepts in gameplay design and programming that do not translate one-to-one in multiplayer. So, when coming from single player to multiplayer, the first question we often get is, okay, what does adding multiplayer to a game actually mean? And I really do want to emphasize the word add, because what we often get as a misconception is this. Oh, we have developed our game, we have developed a single player game, now we want to add a multiplayer component. This is unfortunately never how it was, nor how it is today. In the past, early 2000s, actually this is what multiplayer game development looked like for a lot of games, meaning it wasn't actually a component of the game, but it was developed completely separately, sometimes even in different engines, as we've seen, for instance, in the early Splinter Cell games that had multiplayer components. But that was in the past. Today, multiplayer is actually a core feature. And the core feature aspect is very important because the technology that you require to actually build multiplayer games, regardless of what type of game we're talking about, is essentially at a lower level than the engine itself, usually. Which means that instead of it being something that you add to the game or that is just a factor in it, it is something so fundamental that it will have implications through your system design, through your animation and your art, and of course, your programming aspect, let alone production, maintenance, and everything else. So it is not something that you look at after the fact. It is something that you have from the beginning when you make your planning, whether it is for design, programming, or again, production in general. Which leads us, of course, to the question, well, do we do single player or do we do multiplayer? And the answer is not really either or, but rather it is both. Just like we have seen in web development in the early 2010s, when all the web design agencies decided to go mobile first because that was the most restrictive platform, and they then had a website that could be responsive and work as well on tablets or on PCs. We have the same thing today with game development as far as single player and multiplayer is concerned. If you decide that you want to build a single player game, that is fantastic and you should do that, but because single players games have a bit more leeway as to their requirements in terms of technology, the way you build them doesn't mean that they can translate to being a multiplayer game. On the other hand, if you do start with a multiplayer tech stack as a foundation, you will be able to actually run this either as a multiplayer game or as a single player game, because the technology itself is available to be run offline as long as you follow the right patterns. So here again, you basically do get both for the price of one if you do that from the very beginning. Now, as I mentioned before, technologies. There are two technology stacks. There have been two technology stacks for the last 40 years. This has not changed. And there are four topologies. What does that exactly mean? Well, first off, among the two technologies, there's only two, no more, no less. And regardless of what new fancy word we find to describe them, it has always been this case. The two in question are what we call state transfer and determinism. State transfer is the most popular one, the one that has been around and actually been seen in active game development since the 90s. And determinism has, up until recently, been a relatively niche type of technology. But these words don't really mean much to people that are new to the multiplayer space. So let me translate that to something that might be a bit more palatable. State transfer is essentially a technology that allows you to synchronize the actual gameplay state of your game, of the different objects, the different actors, what will you. Whereas determinism is actually about input synchronization. So all the simulation is local and the only thing that is being exchanged is inputs. There is a large difference between what that means for your games, but again, that is something we have discussed in the past, and that is a bit too in-depth. The important part that you need to consider is this. There's only these two types of technology, and if anybody comes with something new or a different word, try to ask them what they actually mean. The technologies themselves translated what we call topologies and authority. The topology is essentially the infrastructure that is required to run the game, whereas the authority is who has the right to say what is true in the game. As we're focusing on state transfer today, as I mentioned, there are four topologies, and well, three of them are actually in state transfer itself. The first one, servers, is probably the one that most people have heard of, the ones where you do run a dedicated server. It is also the most expensive way to run your multiplayer game because, well, servers, both the hardware as well as the bandwidth, are fairly pricey, let alone the actual CPU time in the cloud. The second one that is also fairly known and is essentially the same is called the host topology, where one of the game clients actually hosts a game and acts as the dedicated server. This gives you most of the benefits of the dedicated service without any of the associated costs. Now, the final one, shared as we call it internally, or client authoritative as you might have heard it elsewhere, is basically where the authority and the right to say what is true is being shared between the different clients. So every client in your simulation, every player can say, this is the actual true state for what I'm controlling, and well, everybody just deal with it. The important part is all of these topologies are connecting clients to servers and servers to clients. Those are all peers, which brings us to another thing that we need to clarify when it comes to multiplayer. Peer-to-peer. It's dead, but it's still in use. And this is something that we do need to clarify because this is a big misconception as to what you should be doing or what actually the different topologies do. The true peer-to-peer, as we commonly actually still have it in mind, is what is more similar to a mesh network, where everybody in the game connects to everybody else in the game. This is something that does not scale, simply because it means that the amount of connection and traffic that you're generating over the internet is, well, O(n) squared. That means for every connection that is there, you add a total amount equal to the existing amount of clients. And this is bad for two reasons. First, that means you don't have control over the actual latency between any given client because two clients might be, in the same city, different countries, whatever. That means the information that is being shared in the same game, you have absolutely no idea when it will actually arrive. The other thing, and that is much more of a, well, societal issue actually, is the traffic it generates. The amount of data that games have to send means that we're basically clogging up the internet if we do this constantly. So both for the internet itself as well for us as game developers, we moved over the years to what we call client server in general. What that means in practice is essentially, instead of connecting everybody to everybody else, we have everybody connect to one single peer. In the terms of client host, that is just another client. And in the term of dedicated servers or client authoritative simulations that are connected through the cloud, that means they connect to one server in the cloud that is connected to everybody else. What that allows you to do is, first off, you have a better idea of what actually the timing is when information is being sent and received, but also, of course, you have a lot less connections. Now, moving on from the actual way this is built, I want to kind of return to what I said earlier regarding adding multiplayer. It wasn't entirely true, but you get the point before. The important aspect of client authority that we just discussed is that since everybody can actually control their own state, if you have a game that is not competitive, it's just a co-op game or something that is casual amongst friends, you can actually do this. It just means that you as a game developer have relinquished all the control over what the true state is of the game to the clients, and basically everybody can act like Cartman here, and trust has to be there, which can be good or, bad in the case of a competitive game. Which is why if you do want to build something competitive, you have to trust but verify. And this is really where the client host and dedicated server topologies come into play. Having a single source of truth that everybody actually looks up to means that you have control over the information. It means also that you can validate or invalidate, which is more important almost, what has been just happening in the game. Having one source of truth allows you to also predict outcomes on the local clients and then wait for confirmation from the one true, all-knowing source, in this case, the game server. And as we all know, the answer to everything, life, and the universe is always 42. But maybe in your case, it's a bit different. So the aspect that is really important here to keep in mind is time. Timing is everything. Timing is something that you will not get around. And the reason why it is so important is because we, as people, just usually think of the internet as this fantastic thing where information goes from A to B instantly. And while this is how we perceive it for a lot of applications that are not games, so if you're watching Netflix or YouTube, you have buffering in the background, so when you get to the point where you need a certain piece of data, it's already on your local machine. In games, we have the issue that everything is happening in real time, everywhere, all at once, and we need to be able to receive, or at least give the player the perception that something has been received, even if they don't. And the problem here is really a physical one, because this is actually more how the internet looks like. It's a bunch of cables, bunch of routers everywhere, which means latency is not something that will ever go away. Physically speaking, we are limited by the speed of light, at best. Now, as you can imagine, infrastructure is never the best. There's a bunch of issues, there's routing, there's congestion. And so when you are working with multiplayer, you have to factor in at every step of the way that by the time a client, so a player, receives the information either from another player, in the case of client authority, or from the single source of truth in client host or dedicated server, they will actually already be further in the future, since the information has had time to travel through the internet and therefore is essentially old already. And this means that it impacts everything that you design for. You have to use smoke and mirrors. You have to account in both the way you animate your actions, the way you create your skills, the way you give feedback to the players to afford the actual information to travel through the internet. There is no such thing as negative latency, as we've heard a couple of years ago. There is a combination of both technology but also design solutions to give that impression that everything is happening right now, immediately, locally. But it actually isn't from a purely system perspective. So one thing, of course, that is important here in state transfer is also to care about, since we have to transfer the actual game state to everybody. And as you can imagine, if you have a large game, if we take about a battle royale game, for instance, sending the information of 100 players to everybody at all times is just unrealistic. It would get fragmented over the internet, packets can get lost, that means all the information has to be resent, and that would not be realistic. So in order to handle large worlds that have too much data to be sent or be useful to all the players, there is a very important feature that we have to keep in mind, which is interest management. And the most known application of interest management is the so-called area of interest, which basically means you're only sending information to a given player about the current area that they're interested in. Now, this does not have to be a single area in the game. It can be, if we're very simple, just the area around them in a 10-meter radius. Or it could be, well, what's just in front of them, what's just behind them, to account for the fact that they might turn around. It could be their home base and, the place that they're currently on the map. But the important part is that we as developers have the ability to decide, okay, you will only receive these pieces of information, which on one hand gives us the ability to secure information on the server so that not everybody is always aware about everything, to avoid things like wall hacks or just seeing a map where everybody would be currently standing. But it also allows us to basically minimize the amount of data that we send to any given player. What data that is, that is up to you to decide. Now, as I mentioned, everything's in the game state. But the question you have to ask yourself is the game state really something that we need locally or networked? Because not everything that you're currently simulating has to be 100% correct or even shared. There is a lot of information that you can derive from existing information. So let me give you a practical example. If you're having a game where, for instance, you're throwing grenades, like in the original Halo games, do you really need to synchronize all the positions of the particles, the way the grenade bounces and everything? Well, you could. There's nothing stopping you from doing so. But the question is, why do you have to have all this data? Usually it is to play, the VFX, the sound, the sizes, what will you? But if we just analyze this picture, the actual thing we do care about as a developer when we are replicating, the game field, the game simulation locally to the player is this: the position and the type of the grenade in this case. Where has it landed? Well, where is it currently in the world? And the type, so, if it's, for instance, a frag grenade, does it bounce around? Or in the case of plasma grenades in Halo, is it something that just goes to a wall and then drops? Or does it stick to players? But this is really the only information that you need to synchronize. Because based off that information, you can then decide, oh, okay, I know this is a frag grenade, so we probably have more realistic fire particle effects. These are things that you have already decided at edit time when you're actually creating your game. It's not something that changes at runtime usually. And even if you do, well, then you can synchronize it. But most of the time, you know what kind of grenades you have. The explosion size is, again, something that you usually have derived either from the type of grenade it is or the abilities of the player. So this is information that you already have saved in one way or another. Now, as we mentioned, we also have the SFX type. All of these things are aspects that you don't need to synchronize, that you can save bandwidth with. Now, how the actual effects are of this thing on the rest of the game is also not necessarily something that you need to synchronize, because if we take, for instance, ragdolls, this is a purely visual effect. It does matter whether, a character that you're seeing on your screen that's already dead, that's not an active player, has one hand, with the left finger that goes a bit up or a bit down. That is something that you don't really care about. It's not going to impact the player experience as heavily. So for instance, once you have the explosion size and the explosion force, you can just run the physics simulation for the ragdolls locally, thus again, giving all the feedback that you want to players without having to share all the information. Which brings us to feedback. Feedback systems are the A and O of not only game feel, as we know that from single players, but in multiplayer as well, the way that you will be showing, and more importantly also hiding, latency to players. And the most important part here that you will have to use when coming from single player and that you have to adjust is the way you think about animation. Now, when we come from single player, a lot of the animation, whether it's root motion, animation events and everything, it runs on one single machine. You can trust that, okay, if A has happened, B will happen in that sequence with that time. It is not something that you have to coordinate between different clients in different local and remote times. So the question you have to ask yourself when using animation as feedback in multiplayer games is it purely visual, or is it actually something that is tied into gameplay? If you're talking, for instance, just walking animations and everything, this is feedback to player input. It is not something that has to be synchronized, again, perfect in lockstep among all the clients. Therefore, this is something you can run locally off the information you already have. As we said before, deriving what you need for the animation from, for instance, input data or your character controller. However, if your animation ties into gameplay and has immediate effects either on other players or the environment, then you get into a situation where a lot more data is required and honestly a lot more complexity as well. Take a fighting game, for instance. Where you're hitting, how you're hitting, what is the exact position of the animation in a given time is incredibly important. However, building this in a state transfer stack would be very cumbersome. And this is, for instance, one of the reasons why, in the case of fighting games, you would probably prefer using a deterministic stack over a state transfer stack. And so the way you're building your animation pipeline, and whether it is tied into gameplay or whether it is something that is just providing feedback to the player actions or to the actions of other players, means that they have to be more or less decoupled from your actual gameplay system and the actual simulation of the world itself. This is very notable, most of all, again, in movement. As we mentioned before, time is something very complex in multiplayer games. Information needs time to travel between the net. And prediction in video games is working off what we call the dead reckoning, meaning we are currently assuming that everything that's currently happening in the simulation, whether it is the behaviors of the enemy or more importantly, the input of other players, will remain constant. And if we take the case of movement, it means, if a player is moving forward, we assume they're still moving forward in the next frame. However, well, humans are irrational and reckless, so they might just decide to stop for whatever reason. And in that case, because movement stop is just like a very abrupt action, something that you could not possibly predict, then what might happen is that for the other players, the character will move and then stop and then be pulled backwards because the server says, no, wait a second, that player is not actually 5 meters in front of them, they're still, 3 meters behind, they stop there. And this is when you have to start thinking, okay, what in this case of locomotion or of movement is the right solution? Do you make movement slower? Do you add, like one of the most common solution would be to add a braking factor so that the character stops almost immediately, but not quite, just to give it a fraction of a second to propagate the movement stop. These are all things that affect animation more than any other aspect of game development. So do really keep in mind that whatever you decide to do, whatever you decide to present to players is not happening immediately. It will happen with a tiny bit of delay. And this is also why audio and VFX are so important. We as humans have, 5 senses, sorry. And as far as video games are concerned, especially if we, take the case of a PC game, we only really can talk about visual and auditory senses. If we have a gamepad, we might have, touch still with rumble. And yes, I know we're getting to like smelling and tasting technology, but those, as we all know, is not commercially available yet. So maybe in a few years we'll have more senses to deal with. But for now, those are the two that we have available to us. And so if we take this from an interaction perspective, what does it actually mean? Well, how can we use them? Well, we have to think about, okay, what happens, what does the player do right now? What are they expecting? And how can we confirm or cancel that effect once we get the reception from the server that the action has, landed or been missed? And my favorite example for that are headshots, for instance, in Counter-Strike. As a player, what I expect to happen is that if I press a button, something is going to happen. What that is, I don't know. But something needs to confirm that I did indeed locally press shoot. What happens in the case of Counter-Strike is you have the animation and a small VFX for the muzzle burst. Now, then you have a tiny delay, and once the server actually confirms the hit, an SFX is triggered, that the shot has landed. You hear the shot from your gun, and then you hit the shot landing on the character. If that happens, you hear first the SFX, then the VFX gets triggered on the actual character locally to give you also visual confirmation, not only auditory. And finally, we have the rest of the local displays that get updated. This is all actions that happen with a microsecond of difference, but allow you, for instance, if, which it has happened to me just countless times, I press a button but I actually got killed in between. So I will have heard the shot that I did, but I will not have heard the actual confirmation that I got a point. And this allows you to manage player expectation as to what happened and whether or not that did happen, in your head or actually in the game. Now, this is all good, but let's move on to the next subject that is critical for, most games as well, which is physics. Now, for physics and state transfer, that's usually a bad combination. That's a short story. The reason is here again, in state transfer, we're synchronizing the actual state of the gameplay. And physics, anybody who has worked on like physics-driven games knows how many things are happening there and how much information you have to deal with at any given point. If you were trying to synchronize all of the state of the physics engine, you wouldn't have any data left to like synchronize what's actually relevant to the players. So if you do deal with physics in state transfer games, you have to basically decide, is this something that we do need to handle on the server? Is it something that the client can predict, but that we do not trust because, again, since all the clients run it differently, you might get different results? Or is this a case, again, where you go, well, physics is too important, it's key to the gameplay, we need a deterministic stack where we only synchronize the input and where we know we will get the same results for all physics interaction at any given point? So physics is one of these cases where you definitely want to design your gameplay and then see how much of the physics interaction itself is, again, visual candy. Like, if you have a chain that moves when a player runs into it, that's not something you need to synchronize. But if it's something that does apply and change the game state, then a lot of vectors of potential error come in. And so this is one of the key aspects you have to look into should you have physics-driven gameplay. And so, of course, you need to plan ahead. As we said, small things that we're used to in single player might be radically different. And so the first one, just to kind of repeat myself and really, really, really hammer the point home, is time. Time is relative. Time's a mess. Do test with different types of latency. Do everything you can to afford the time, both in your systems and your feedback, to have this delay happen. I cannot emphasize enough how important this is. But of course, part of the things that you do need to do when developing a game is testing stuff. And one thing that we do like as programmers is statics, because it allows us to grab data in certain points. But in multiplayer, you're most likely going to run several clients locally to just do tests. Or worse, you will actually also run several game instances on the same server. And so statics are usable, but you have to be extremely careful because anything that is a shared resource at some point or another might be different between two game sessions and result in things that are, well, just plain wrong at best and, well, crash your game at worst. So static is some things that you will want to revisit, anything from pooling to just data that is shared. If it's read-only, of course, that's not an issue because it doesn't change. But if it's something that you have to grab and edit at runtime, you have to be treading carefully and maybe look at rather singleton instances over static singletons, just so that you don't have any overlap between the different clients or the different instances running on the server. Which brings us to testing. Testing is, well, incredibly important. I don't have to explain to you why QA is critical in game development. But there are a couple of additional things that happen when you do multiplayer game testing. And the first one is actually something that you don't think about until it happens, and that is the amount of clients that you can run on a given machine to test, for instance, for load, or the amount of players you can cram into a session. Now, the issue that we're facing here is simply that if you have X amount of clients, which really depends on how much you can run on a machine, on how much you need in a game, and you run those from the same IP, the same MAC address, then most systems, including your own firewall, may actually detect that as a DDoS and just cut the connection. So when you run these kind of tests, there's also a structural level, an infrastructure level that you do need to investigate and make sure that you're set up for, because otherwise you might actually not be able to test or have it delayed because of these kind of automatic blocks that you have both on your end as well, of course, on the server end. And speaking of infrastructure and load testing, there is a couple of more aspects that you do need to consider when running these things. Number one is, of course, the amount of bandwidth that you consume up and down. Now, this is incredibly important for two reasons. One is, of course, do you have your game state optimized to really just share what is absolutely needed? But it's also important because of the devices in the countries that you're targeting. For instance, is your game playable in the Philippines or only in Poland? Is it a game that is being played on mobile, or is it something that's played on a home console? Is it something that is being played over Wi-Fi, or do you require a hardwired connection? All of these factors will impact latency, the amount of data that gets lost in transit. And so it's really not about only testing the amount of clients, the speed of information, but it's also to actually test what are the conditions, the circumstances in which different players are, and if they are, for instance, an Xbox connected via Ethernet, will that still be a good experience with somebody that plays on a mobile on 3G, assuming those are your target platforms? So testing is a lot wider in scope than it is for single-player games on those kind. And finally, of course, the dedicated service. But that's a story for another time. Thank you much for your attention, and I'm open for questions if you have any.
Thank you, Timothy. So do you have any questions? Yes? No? Okay, please.
Hi. So I'm not a specialist, but you were talking about two topologies, like, let's say, peer-to-peer and client-server, let's say. And I believe that both have advantages and disadvantages. Why not to use some kind of mix? I say my client-server, client-to-server, and then connect.
Well, so peer-to-peer, again, I stay away from that word very consciously, because there are a lot of like misunderstandings and implications in that. So you're talking about client authority versus server authority. Like essentially the clients themselves decide what is correct versus the server telling the clients, yes, this is true or not. Now, you could technically have a dedicated game server and clients saying, okay, this is true, but then you're losing the advantage of both, because you don't have the advantage of resource saving, where everybody just says, hey, that's the truth, accept it, and you don't have any of the advantages of having a single source of truth. So you incur the costs of a dedicated server without having any of the financial or gameplay security benefits of having it. So it's not a technical limitation, it's just that it doesn't give much benefits to mix them. You usually have one or the other depending on what your needs are.
Okay. So do you have any questions? No? Okay. Thank you very much, Timothy, for your...
Thank you all, and have a great Digital Dragon.